heavy. And what does an asteroid consist of?
It's an iron nickel meteorite, so it consists mostly of iron, and about 6% of nickel and stuff like gold or uranium or stuff like this. So this was once the core of a small planet. It was destroyed at the beginning of our solar system. So first there were very, very many small planets, and there were too many, and then there was some collisions, and then you have here the remains of a young planet.
How old is this young planet in my small hand?
About 4.5 billion years.
Where was this found, this asteroid?
In Argentina. So it's the place is called Campo de Cielo, so a field of heaven actually, and it was a large piece of iron falling through the sky, and it broke down into parts when it landed, and the largest part I think was about 36 tons, and it's called I think El Chaco. So, and this is still in Argentina, and we have a small part here, and it's quite nice.
It's very small, but it is very dense and very heavy. I wouldn't thought.
Yes.
I mean, I'm shivering, shaking, having something in my hand which is billion of years old. How many asteroids are flying around Earth right now?
Now.
What is the distance of those asteroids? I know, like lately, in the last quarter, 17, there was an asteroid in the shape of a cigar, right? Have you seen that?
Yes.
That was a monster.
This was something special because this asteroid did not belong to our solar system. This is the same stuff, which is all the planets are made from that same stuff. This is as old as our solar system because it started at the same time. It's as old as our sun, 4.5 billion years. But this thing was not from here. It came from far, far away.
How far?
We don't know. That's probably.
And how far did it pass? How close was it to Earth?
Not so close. I don't. Well, far enough away that it isn't a danger to us. It looked like a cigar, and we would really, really love to get a piece of this rock, so that we can measure how old it actually is.
And what is the purpose of an asteroid going around the galaxy? Like, I mean, are they pulled by what kind of forces are they pulled?
Somehow this thing was thrown out of its own solar system. Maybe just a collision or just some interaction with gravity and another planet. So it was thrown out of its own solar system, and then it was somehow caught by our sun, by the gravity of our sun. So it goes around the sun and goes away again. And exactly this orbit tells us it isn't from here, because it comes from far, far away and goes away again. And this we know, this isn't our stuff, it's something else. Well, on the first time you looked at it, it looked like there is small amounts of gold in there. Just the same way there are small amounts of gold within our Earth's core. So therefore you find gold in volcanoes and so. But if you have here, this is iron, there's nickel inside, and rare metals. So it would be interesting to really use those things. So the problem is, those asteroids are actually, most of them are in the asteroid belt. And the asteroid belt is between Mars and Jupiter. So the first thing is, go back. How do we get them back to Earth? What do we do? So we think we have to go to Mars first, and then we can harvest the asteroids. Because if we go to Mars, then we have the technology to actually harvest those nice rocks, or piece of iron and stuff like that. And then maybe we can build a city on Mars, live on Mars. It's nice there.
Is humanity heading towards, should we inhabit the moon or Mars first?
I think the first step would be moon, just to test out things.
Because of its distance?
Its distance. It's far easier to go to the moon. You need 3 days.
Yeah.
To Mars you need 6 months.
I know. My name has been on a microchip.
Yes.
NASA's taking off, I think, in May, and they'll take 6 months to go to Mars. But the surface of it said that Mars billion years ago used to be like Earth until
Yes.
Can you explain exactly if there was a possibility of life there and what was the
Mars, like Earth, is within the habitable zone. It means that there is liquid water. The problem with Mars is it's about half the size of Earth. This means it has the gravity of Mars is not enough to hold its own atmosphere. It had an atmosphere once because there was volcanic activity. Still today you see the volcanoes on Mars, the largest mountains in the solar system, like Olympus Mons. It's about 27 kilometers in height. But there is no eruption now. So Mars loses the atmosphere and there is nothing which refills the atmosphere. This is what the volcanoes were actually doing, refilling the atmosphere. But now they don't erupt anymore. And therefore, there's no refilling of atmosphere and the atmosphere goes away. And therefore, the water just evaporated and it's gone now. And maybe there is still some kind of life on Mars. This is what we try to find. Actually, this is what the people try to find which bring those Mars rovers there. They look for life on Mars. Fossil life, maybe. Extinct life, but maybe there is still something there. We don't know. So,
and what is your personal purpose?
I'm doing outreach actually. So my personal purpose is to tell people, especially children and teenagers, that physics is cool.
What is your long-term vision of humanity?
That we hope for learn to be nice to this planet. And maybe that we can reach Mars without too much problems. And maybe we should do it all together and not say, okay.
Do you think it's a necessity for humanity to move multi-planetary?
Maybe, not a necessity, but it would be nice. Humans are curious. And we want to know what's out there. And maybe Mars is a nice planet, and maybe we can just have a look, and then from there we can spread, right? Maybe just in our solar system. Maybe we never manage to go to the distance, the more distance, to another solar system. But maybe we can start with Mars.
And how does technology play a role here with the future of humanity and how we evolve? Would you the notion of either humanity has always, and any species that ever has been around, either we live, we adapt, or we die, right? So if the dinosaurs would have a space program, maybe would they still be around? Is that the question? Probably yes. So
this is technology. Dinosaurs were killed by us, by a thing like that, the size of 10 kilometers. If the dinosaurs actually had the space program, or even had telescopes to discover this nice little rock, maybe they could have destroyed it, and then they could have lived. Maybe, this is really a problem. Sometime in the future there will be a meteorite that big, and it will hit Earth. So we should know how to destroy.
We have an exit plan to better have a backup plan than no plan.
Maybe we actually can be faster than light. We don't know. Maybe we find a wormhole, can go through it, visit the next solar system. Maybe, we don't know. So, but now we can, with the technology, it's like when we want to harvest those things, if we have the technology to harvest an asteroid, we have also the technology to save Earth from such a thing. So, yeah, I think this is good.
Comes into mind that the Interstellar movie has been written based on the string theory, right?
Yes.
Can you elaborate on that?
What
happens when we throw
Interstellar? Actually,
what happens when we fall into a black hole? Like this actor, he comes back. He comes back. He's younger than his daughter, and his daughter is on deathbed. His job is to save the world and find an exit plan in case shit hit the fan.
So I mean, if you are nearer to a black hole, it's just that time moves slower relative to someone.
So what happens
further
when
away.
when a human being falls into a black hole?
He will be dead. Definitely dead.
Don't we turn into spaghetti when time slows down?
Yes, they turn into spaghetti.
And then we turn into small molecules, right?
Yes, like you will be evaporized.
and then what happens then?
Then you just fall into the black hole.
And what happens then?
And then you are in there, and then you stay in there forever.
Or on those when the stars collapse, that they build new galaxies?
No, a black hole is actually just a big, heavy piece of matter, which is so heavy that gravity takes everything, even light. So it's just, we don't know what a black hole actually is. That is the problem, because everything falls into it. And in astronomy, what the information you get is from the light of an object. You don't get any light from a black hole. So you don't have any information what's actually in there. And that is the problem. We have the theory of relativity. It doesn't tell you what a black hole is. You have quantum mechanics. It doesn't tell you what a black hole is. So we have to find something which we call what you call quantum relativity to actually find out what a black hole is, but we don't know. We don't know. So if anybody is outside there and now has any ideas what a black hole is, please tell us.
I know that Stephen Hawking, he designed nano chips to help us to travel interstellar.
Yes.
Can you elaborate on that?
At least he tried so that there's something that you actually can manage to go from one point to the other, not through normal space, but through some tunnels in space-time. So it's actually that it's a shortcut.
It's a shortcut.
But you should not do the shortcut through a black hole, because then you're dead.
Then you're dead. Maybe you're not dead because you don't know what a black hole is.
But we have a lot of black holes in our galaxy alone.
How many?
We have one very big one, a supermassive black hole in the center.
What's its name?
Black hole. So center of the of our Milky Way. It's called a Sagittarius A star. This is the black hole, and there are about 10 billion stellar black holes, which is the remains of very big stars collapsing. And if a black hole actually had an exit, you would see it, right? But there is nothing like that. So if you are in a black hole, you stay in a black hole. Maybe there's a chance that the Hawking radiation can go away, but it's just a little bit of light, which the black holes will radiate away over a long time. But I think if you fall into a black hole, then bye-bye. You will be spaghetti, and then the black hole will eat you.
What? To share your story, what have you led you to study astrophysics? Have you always been interested in stars?
I started with particle physics, actually. So even as a child, I loved to investigate. So I investigate every stone I found, every insect I could catch, and then I decided, okay, physics is cool. And then I was very happy, and it didn't stop until now. And I can only say physics is cool. Astrophysics is even cooler. And yeah, it's a lot of fun.
Okay, what would you advise children that are heading towards the future? What skills and jobs that be interested that will evolve humanity?
Not even jobs or something like that. I think what's the most important thing, to stay curious.
Yeah.
To try to investigate. If something bothers you, just try to find out what it is. Have a look.
Ask questions. Learn
Yes.
how to think.
Think for yourself. Don't run around and believe everything, right?
Which school doesn't teach you, right?
Yes. Just ask questions from everyone. It doesn't matter what you are asking about. Just ask things. This is important, even if it's about history, if it's about natural science, it's about, I don't know, cooking. It doesn't matter. Just stay curious. I think this is the most important thing. If you just stay like this and just ask nothing, there is no progress. There is no progress, and I think this we shouldn't do. We just stay curious, and I think we are a very curious species. We want to know things.